Thanks, everybody. If you buy me a beer, I'll tell you the Snoop Dogg story. So this is kind of a bold premise for a presentation at a web performance conference. I'm not actually going to tell you how to optimize your web performance, but I have a reason. Performance is actually more than optimization. There's this acronym MOM, Measure, Optimize, Monitor. I'm going to talk about the M's, measurement and monitoring. So I am Rick Viscomi. I co-wrote using Web Page Test. I'm also the host of the State of the Web video series. My day job is a senior developer programs engineer at Google. And what that means is that I'm kind of a developer advocate. I work very closely with the web community. And I also work very closely with engineers at Google, so the Chrome team, and also standards bodies, making sure that we have capabilities on the web in tune with what developers need and what users need. I'm kind of a steward of the CrUX and HTTP archive datasets. I help maintain the datasets, maintain the integrity of the datasets. So we're going to be talking about those two tools today, and specifically web transparency. What does that mean? So when we're tasked with understanding how a single website or web page is performing, what do? We use RUM data from the field using tools like Google Analytics, Akamai Impulse, or SpeedCurve Lux to measure real user experiences in the wild. And it's a whole distribution of user experience. It's not any one representative user that you can just point to and say, that's what using this website is like. It's a distribution. We also use lab tools like Web Page Test and Lighthouse to do deep dives into how each page is built and how they can be improved. So web transparency is taking this to the next level. It's not just how is the website built or performing, it's how is the web performing. And to answer that question, we need tools that scale to the size of the web. For example, on the order of millions of websites if we're just sampling it. So the tools that we use to understand the performance of the web are the Chrome User Experience Report, or CrUX for short, and HTTP Archive for field and lab data. You might have also heard field and lab referred to as RUM and synthetic. So we're going to dive into what these tools are and how to use them to extract insights about the state of the web. Starting with the Chrome UX Report. It was launched at Chrome Developers Summit 2 years ago. So we've started collecting data about real user experiences in what started to be a BigQuery dataset. And the data pipeline looks like this. First, we collect user experiences from real Chrome users who opt in, user performance, user experience metrics like paint, page load, and interactivity, some of those real metrics that you heard about earlier. Also, UX metadata like the country that the user is in, what device they're on, what their effective connection type is. So we're on conference or university Wi-Fi right now. If that's congested, even though that's Wi-Fi, it might be more like 3G if you were on a mobile network. So we use effective connection types in mobile terms like 4G, 3G, 2G, and also offline. The data is aggregated. So we toss out any websites that have low confidence, for example, if there are too few samples to have an accurate distribution. So smaller websites will not be included. Right now the dataset has 5 million origins in it, so most of the popular ones will be in there. We bucket these distributions into histograms. The resolution is 200 milliseconds, which is enough to get by. It's not the raw data, but it's pretty low level for most use cases. And the collection is continuous. We just snip the latest 30 days on a daily and monthly basis. The BigQuery datasets that you can write queries against are monthly datasets. As we'll see in a few slides, PageSpeed Insights uses daily aggregation. Also, third parties leverage these data sets to provide additional tools and capabilities that we'll see in a little bit to really make it interesting to monitor your performance. But I do want to say what CrUX isn't. It's not a replacement for your first-party RUM. If you want to know how fast your website is, you should instrument it with first-party RUM tools like I mentioned before, Google Analytics and so on. What this tool does is it's a common baseline for all websites in our data set using the lowest common denominators of metrics that we have. For example, first contentful paint, first input delay, onload, and DOM content loaded. So CrUX data is made available in several tools, starting with the CrUX dashboard. You could just give it an origin. And by the way, an origin, that's how the websites are grouped in the data set. An origin is just the protocol subdomain and domain. For example, http://www.example.com. There's no trailing slash or index.html or anything. So the CrUX dashboard will generate a dashboard complete with graphs already built for you. It's shareable, just like a Google Doc. It's embeddable. You can have your dashboard embedded on some page, like a monitor in your office, to keep track of what things look like. So all you need to do is visit bit.ly/CrUX dashboard for a walkthrough of how to create your own dashboard. Also, earlier Chris mentioned car and driver, and I was actually able to pull the CrUX report for this website, and you can see when they made their improvement. Like he was saying, the before and after, you can actually measure how much faster it got, like the percent of user experiences that got faster using FCP. So this dashboard is really useful. It also provides those metadata descriptors that I mentioned earlier, like the country and device and connection type. So you can see on a given website what their breakdown is of mobile versus desktop, or 4G and 3G. Even tablet usage is logged here, so it's super useful. And you can trend it over time. On PageSpeed Insights, you can enter the URL, the full URL of a web page, and you can see the performance distribution of that specific web page. It's really useful. You can't query for this in BigQuery directly because we don't want to allow people to just say, like, give me all the web pages for a given website, just in case there's any user identifiable information in there. This is the trailing 30-day window. It's updated daily. And this data is use it or lose it. If you don't query it and store this data, you can't go back and get yesterday's data. But there are some interesting things that you could do with it because PageSpeed Insights has an API. I wrote a post on the dev.to website about competitive analysis using this API, and you can give it a few different websites, let's say me and my competitors, and you can track them every day and see how their performance is changing. So that will make a very compelling graph if you want to show that to your managers or your CEO or anything. Like, hey, look how much faster our competitors are. And that, I find, is a really good motivator to get them to care about web performance. PageSpeed Insights only gives you first contentful paint and first input delay data. So it's not the complete data set that we have in BigQuery. It doesn't give you the full distribution, just the fast, average, slow breakdown. Fast for FCP is everything less than 1 second. Slow is everything greater than 2.5 seconds. FID is 50 milliseconds and 250 milliseconds. And it also gives you a label. So it'll say this page, and it also gives you origin level data. This page or this origin is labeled fast, or this page is labeled slow. A lot of people look at that and they're like, Google.com will show up as slow on PageSpeed Insights. And like, that's not right. Like, it doesn't actually feel true to reality. And the reason is, it's actually looking at the 90th percentile. We're kind of trained to look at medians, the 50th percentile. So half of our users are this number. The other half are going to be slower than that number by definition. So by moving that goalpost, setting that bar higher to the 90th, and even in FID's case, 95th percentile, we're ensuring that a very small percentage of our users are having slow or bad experiences. So that's why we look at those percentiles. Test My Site is another tool. This is on the thinkwithgoogle.com website. I called this one out. It also uses the BigQuery data under the hood, but it also has something really useful, which is a speed calculator. You can input what the current performance is of a website, and if it's in the CrUX data set, it'll actually pre-populate for you. But if you plug in some analytics data like the number of monthly visitors, what your conversion rate is, how much money you make per conversion, it'll give you an estimation of how much more money you could make if you improve performance by some amount. So you can, like, if there's a slider on here, you can say, if I improve performance by 500 milliseconds, then it'll say you can make $100,000 more dollars. So that is also another very compelling tool. And I've been talking about BigQuery a lot. The raw data on here is really where we're going to extract insights about the web as a whole. This allows us to write aggregate queries so we can see what is the average performance for this or that. 5 million origins in here. And this is also aggregate at the calendar month. So it's actually a 30-day window. So for example, January will be from the 1st to the 30th, not necessarily including the 31st. Just a little fun fact. The CrUX dashboard is built on top of this data. And in fact, I'll show you a helpful data set that is pre-processed that you have an easier time querying for this data. One of the most important things I think that you can do in BigQuery is the use of the join keyword. We'll see how we can join CrUX data with HTTP archive data to really get interesting insights. This is what the schema looks like. Each row in the CrUX dataset corresponds to a specific origin, its effective connection type, and form factor. So you'll have one row for every combination of desktop and mobile and 3G and 4G. So if you want to know what the overall performance is, you'll have to sum up the densities of these histograms. There are 5 metrics available now: first paint, first contentful paint, DOM content loaded, on load, and first input delays is right now an experimental metric, but it will be graduating soon. It's about to become a web standard. The metrics are organized in histograms. Each histogram has a bin, where the bin has a start and end time in milliseconds, and also a density value. This is a float between 0 and 1, representing the percentage. Here's an illustration of how it works. This actually came from the State of the Web video, just to show that you have a full distribution. And when we talk about the percent of fast experiences, we're just looking at the head, everything less than 1 second. And then we add up that as a cumulative density and compare that number against other websites. So this is a nice benchmark to see which website is faster. So let's start getting our hands dirty with some queries. Here's an example of a query that scans each monthly release for the UX of developers.google.com. It extracts the FCP histogram and accumulates only the FCP density less than 1,000 milliseconds. These slides are also available online if you want to check it out. It's bit.ly/spotlight-crux. This query, by the way, consumes 377 gigabytes. On BigQuery, you get 1 terabyte free per month. And with data sets this large, it can get kind of unwieldy pretty quickly. So you can query this materialized table that's used as the basis of the CrUX dashboard, and it's only 2.5 gigabytes. So you can get a lot more bang for your buck. Also, I have a link at the end for anybody interested who really wants to use BigQuery a lot. I have coupon codes that will give you an additional 10 terabytes worth of credit. So I'll be using the full data set. I won't be using this one just for the sake of explaining how the raw data works, but most queries can totally use this one. It'll be much cheaper. The schema is much simpler. It just does, it has, instead of the full histograms, it calculates the fast FCP, average FCP, and so on. No need to sum them up. So this is what the results look like. It might look really basic, but it's actually really cool. So you can have a time series of performance for a website that's not even under my control. Well, yes, I work at Google, but I could have entered any website into this query, and I could see how it performs over time, like Car and Driver earlier. I think that's one of the coolest things about this data set is third-party RUM. So let's change gears for a second and talk about the HTTP archive. This is how we can understand performance in the lab. It's built on web page test. In fact, it uses hundreds of web page test instances to run millions of websites. The great thing is it's actually synced up with the CrUX data set. So every single origin that's in CrUX, we're hitting the home page once a month in HTTP archive, all 4 or 5 million of it. It used to be the Alexa top 500,000, but last year we started transitioning over to CrUX. And we find that it's a much more useful data set because CrUX is real user data. It comes from Chrome users, web pages that people actually visit. I found that the Alexa dataset got stale pretty quickly. The resolution of the websites was also a little poorer. They would only give us domains at the time. And so, for example, google.com is a collection of websites. There's Docs, there's Gmail, Maps. These are all unique origins, but we would only have google.com and Alexa. So when we're testing google.com, yes, we would know it's rank 1 in Alexa, but now with CrUX, we have so many more origins in the data set, and it's much more representative of the actual web that users visit. So syncing with CrUX is using these joins is what make this web transparency dataset possible, specifically for performance. HTTP Archive has all this information about how web pages are built. So you can see how many bytes did it load, what requests did it make, what was the response of that request. It gives you the headers, the body. So almost anything you could think of, any output from web page test is stored in HTTP Archive. One of the really important things about it that makes this research possible is that it includes Wappalyzer. Wappalyzer is a tool that has over 1,000 different detections of technologies, and by implementing that in web page tests, we can say, for example, give me all of the websites that are built on WordPress. The types of ways that you can analyze the data, it's only available on BigQuery, the raw data, but from there, we also have curated stats and trends on httparchive.org. By the way, I have a bunch of stickers to give out at the end, if you're interested, for CrUX and HA stickers. The web community uses the raw data on BigQuery to do their own analysis. I've seen everything from academics doing their master's thesis based on the state of the web and using HTTP Archive as their sources. I've seen bloggers talk about the average size of a web page exceeded the size of the original game of Doom. It was 3 megabytes or something. So that was like, it was on Wired, their website at the time. So it was super interesting to see how things get picked up in the community. Also, standards bodies use HTTP Archive. If they want to deprecate some feature, they'll use this tool to say, oh wait, it's actually used N% of the web, or these are the use cases that it's being used. So it's incredibly useful to lots of different people. Like I mentioned, the BigQuery dataset is a monthly snapshot. It's been going since 2010. The granularity of insights that we have in this dataset has improved gradually. So we don't have everything. For example, the response bodies have not been there before 2016, nor the HAR data, the metadata. All that was there between 2010 and 2016 was a summary data set of the number of bytes and kind of high-level metrics like that. There are data sets for each major data type. I mentioned that there's HAR file. There's also Lighthouse tests that are run only on the mobile pages, purely for capacity reasons. But I'm glad that you got a primer on Lighthouse in a previous presentation. So any result that web page test tells you, that Lighthouse gives you, all of the audits that it does, you can query that for 5 million websites. You can see what is the median performance PWA score, like Henri had mentioned earlier. Fun fact, I also worked on the SEO audits in Lighthouse. So I've used this tool to look at the distribution of the pass-fail rate of certain SEO audits. But I do want to caution you, beware the quota. You do have this 1 terabyte limit, and especially the response bodies table can quickly exceed that terabyte. We're saving the response bodies of all text-based responses. That's HTML, CSS, JavaScript, which is cool in its own way. You can parse CSS and look for specific things that are being used. I've used this. I have a jQuery plugin, and I was able to use the HTTP Archive to see all of the places that my plugin is being used in the wild. I was both heartened and frightened by the places that I found it, both ends of the spectrum of websites I agree and disagree with. I'll tell you the one that I agree with. It was on the Game of Thrones website. I was hugely humbled. Give me a beer, I'll tell you which website it was on that I hated. So this is what the data looks like on httparchive.org. You get histogram data and also time series of, imagine like smearing that histogram over time. So you can see the median 25th and 75th percentiles for both desktop and mobile overlaid on each other, which is a nice view to see the state of the web in one glance. Sometimes it's not clear, but in the top graph, on the left axis, you're looking at, I think this is like the total byte size of a web page, and on the right axis, it's a accumulation, the CDF, so you can see it increase over time. And it's really interesting to compare the shapes of these histograms and CDFs. On discuss.httparchive.org, we blog about important product announcements. For example, when we switched from semi-monthly to monthly. There's lots of really interesting one-off analyses. For example, if you do your own BigQuery analysis, you can post it on this forum for everybody to see. If you need help with your queries, you can get help here. You can get inspiration from what other people have done. Power users and SQL experts are there to answer your questions, so don't be shy. I'd mentioned Wappalyzer. These are all of the categories that they support. 63 categories for over 1,000 technologies. And so let's see, here's a query for the top 10 CMSs. It's nice that it's kind of a concise query, the approximate top count of the top 10 CMS apps. We're looking at the February dataset. And not surprisingly, WordPress is the top one, and we can kind of see how it trails off from there. So let's put this all together and learn about the performance of the web. To do this, we're going to combine CrUX with HTTP Archive using the fact that they have these 5 million URLs in common. We'll have to join it not in the cleanest way because CrUX has origin levels aggregation while HTTP Archive is URL. It's looking at the home page. So we'll join it just by doing a little string concatenation. You can see that on line 15. This is a little small. It's not totally important to see exactly what the query is. You can also check this out on the slide link I provided. It's on the first slide. I'll go back. So what we're doing here is, first, this inner query is selecting all the URLs of known CMSs using Wappalyzer. The outer query is calculating the fast, average, and slow FCP for each origin in the data set. And we're joining them using this aggregation of URL and origin. This takes 55 gigabytes of your quota to query. But by the way, you could totally use the materialized data set for this too. This is only 5.5 gigabytes. The schema is simpler. You'll also notice that I'm using the average function, and we're kind of trained in web performance to look at medians. I'm using average here so that we can get a distribution that adds up to 100%. If we were to use the median, any given website might not have the median fast plus the median average plus the median slow might not add up to 100%. So this gives us a chart that looks like this for the CMS landscape. It was actually surprisingly easy to come up with a chart like this. So BigQuery allows you to export directly excuse me, to Google Sheets. And you're able to use the charts in Google Sheets to generate bar graphs like this. So let's step back for a second. I will literally step back so I can see this. The most popular CMSs are on the left. The less popular ones are on the right. And you can see the height of the green bar is how fast, or the percent of user experiences that we consider fast for the FCP. Again, this is less than 1 second. WordPress is at 26% fast. The slowest one, I believe, is Wix at about 14%. It's important to keep in mind what the popularity looks like. So I'll kind of go back and forth so you can visually map that. But like 25% of that bar for WordPress is more than the next 5 CMSs combined. So the number of fast WordPress experiences is more than the fast average flow of the next 5 combined. That's important to keep in mind so we don't shame WordPress into being this slow or anything. It's great that they're contributing 1 million fast websites at least. But it is a reminder that a site like Wix has a long way to go. We can also write a query for the fast FCP performance of the top 10 CMSs over time. That was just 1 monthly snapshot. So the only thing special about this query is that we're using a wildcard over the CrUX tables. And we use the table suffix special name, and we alias that to the year and month, and we group it by the month and the CMS. And that generates a chart like this. So we're kind of smearing this distribution over time, and we're just looking at the fast FCP for each one. It's kind of hard to visually map the legend of each color to each one, so I'll annotate. Typo 3, not the most popular CMS, but they have the highest density of fast FCP experiences. Drupal is close behind, Squarespace and WordPress are in the same middle band, and you can see Wix below. I showed a red, yellow, green chart similar to the previous slide around this time. I like to think that Wix saw that and they were like, oh no, we got to get better. And then you can kind of map it at. If that's true, let me know. I'd like to put that in my perf. We can also take a time series of WordPress specifically and smear that over time, and it kind of looks like this. It doesn't really change too much, but this is to show you what's possible using CrUX data, and also combining that with HTTP archive. This is compelling stuff. In the spirit of measurement and monitoring the web, we need accountability. The only way to have that is to make sure that somebody's looking at the data. For example, Wix might have gotten away with low performance if nobody was looking. But in the spirit of web transparency, we're shining a light on the reality of user experiences on the web for the good of user experiences. We want web pages to be fast. We don't want to ship unnecessary bytes over the network because it's more than just performance. It actually costs people real dollars and cents. So this is why transparency is important, so that we can not necessarily shame people. That's always fun, but nobody likes to be shamed. It's for the sake of user experience. So the last type of chart I'll show, and I have a lot of time for questions. We're going to zoom in on WordPress performance in the February data set and look at the entire distribution. So it's one thing to take the average of 1 million websites, but that kind of glosses over the edge cases. So here's a query that looks at a sample of 1,000 WordPress websites. And I tried to do it in a way where it's like an accurate representation. So you'll see things like modulo 1,000. So I get every other 1,000 fast FCP. So here's what that looks like. This is one of my favorite charts that could possibly be produced with this data set. It shows you how quickly fast WordPress websites taper off. And then you get into the median or average area in the center of the chart, which is kind of intersecting with the 25% line horizontally. And it's also important to look at the other colors as well, so that you can see the yellow turns to a shade of red, let's say, as you get into the tail. So if it's not fast, this is telling us that it's probably going to be slow. It's going to be more than 2.5 seconds FCP experience. So I've actually done the same thing with the other 5 CMSs that I highlighted in that time series chart earlier. Here is Drupal, the number 2 CMS. Their average fast FCP is around 40%. So you could see, I'll go back and forth, it's kind of a puffier torso in this graph, a bit more than WordPress. Typo 3, the fastest CMS, fastest by that metric, 49% fast. It's a little bit of a puffier torso still. But the tail drops off very slowly. There are very few super slow origins. This is kind of the ideal. Obviously, we want to see as many fast experiences as possible, but this is a great chart. Kind of a rising tide lifts all ships type of deal. Now we're getting to some of the slower ones. Squarespace, their average fast FCP is around 24%, similar to WordPress actually, but it has a more well-defined yellow average section. It's not really blending in with the red too much. That's really interesting. And Wix, average fast FCP 14%, very deflated torso, very few 50% plus origins, and a very long tail of minimally fast origins. But the yellow is actually quite large, so it's not necessarily that this is a slow CMS. They're just beyond that 1 second threshold to be considered fast. So to help kind of digest these things, I'm just going to go through them in fast order. Sometimes the movement helps to see the patterns. So coming back to our original question, how is the web performing? We used CrUX and HTTP archive data to look at the real user experience. And we only looked at first contentful paint. I don't mean to suggest that FCP is the one metric that tells you how fast a website is. Performance is a distribution, and it's also many metrics. It's not any one metric. We need to look at user-centric metrics, of which FCP is one. Interactivity is also included in CrUX with the first input delay metric. So I strongly encourage everybody, if you're interested in this type of data, query it for yourself. I included these queries in much detail so that you can run it yourselves, modify it for whatever interests you. I'm more than happy to help. You can post about whatever you're querying on the discuss.httparchive.org website. I also want to say that CrUX is constantly evolving. We hope to add more metrics soon. That Rail model, really, we only have loading metrics like onload, which is not a very user-centric metric. DOM content loaded, not very user-centric. But FCP and FID are there. Hopefully we can get other things. I'd love to see, for example, maybe the page weight or what the time to first byte is. So it gives us an idea of backend time. So if you have any suggestions, there is both a Google group and a GitHub repository under the Google Chrome organization. There are links to everything. If not directly in the next slide, it'll take you where you need to go if you follow those links. So thank you. Here are the one-pager links for you to take a picture of if you'd like. Here's my contact information. Feel free to reach out to me if you have any questions at all. And I have plenty of time for questions. Thank you.